Yeah. So let us start the event where introduction to AI with custom vision. So yeah, as I've told, this is mostly targeted for the individuals where they are at least proficient with the what exactly is machine learning and basics of AI. And the next thing is the main motive of our today's session is about just how to deploy a custom vision, how to train a model in the custom vision, as well as how you can test some images in the custom vision portal itself, as well as and using an SDK via an API. So yeah, so I'll just brief about what exactly is AI according to Rick Barza, who is a Microsoft employee. So artificial intelligence is computers doing things that we would normally think of as intelligent in humans. Seems a bit confusing, but yeah, it in simple words, I can put it in a way such that AI is a cognitive ability of the humans given to the computers. In the previous days, the computers were in such a way that you need to program one thing for the computers just executes that. If you program a computer as displaying an image of something and fetching some data from the database and displaying in a web application, if that is your program, the computer just does the thing, whatever you have done. If there is no data in the database, the computer obviously throws in and stuffs over there. But as we the humans, we who have a cognitive intelligence and cognitive ability to think, we are giving the same thing to the machine. So that is called artificial intelligence. So in the same case, what I've discussed right now, where there is no data in the database or in the okay. So how the normal computer handles the situation is that it just throws an exception or error. But if that computer is trained on a machine learning model, it just goes on iterations on learning the errors that it got, and it has the capability of inserting some data, fetching some data from the another database which is related to that, or proceeding with the cache data, or proceeding with some regional edge server data. So it is quite intelligent. So we are not just making the computer to do what it does, but we are giving the power, we are empowering the computers, on some previously trained data, such that it could perform better without any explicit coding in different situations and scenarios. I just wanted to discuss this analogy with human beings, actually the AI analogy with human beings. So in this, we as a human beings take the sensory input and we process in our brain, which is a machine learning model, and we do act on the environment by some behavior, basically. So this sensory input is the data in the case of the robot. Okay. And the answers here, the answers or the behavior is the answer that the AI bot will give as an output for us. So this data is fine and the answer part is fine. But what exactly is this model? That is what exactly we are going to concentrate on. What exactly is the model? So if I come to the humans, our model is our brain. Let's take a scenario where you are a child, where you are a 3 or 4 or 5 year child. I hope so. Most of us have at that age went to the kitchen where our moms used to cook something, and our parents usually tell us not to touch something on the stove, because they know that we may get hurt by that utensils on the stove because they are hot. But we doesn't know that, right? At 3 or 4 years we doesn't know that. So once what we do is like we just go and touch that utensil or vessel. Then we know that, okay, if I touch the obstacle, so if I touch the utensil on the stove, so I get hurted and I feel hot. So this is what we are learning from the past experiences. From the childhood onwards, a human even learns from its past experiences. So that is what we have taken an advantage, and we have trained it to a machine learning model, where we'll train a model based on the past experiences. So we'll be showing some some scenarios to the machines to learn and to grow on that past experiences, and we'll give some test data to that. So essentially it could give an output based on the previous experiences. Even the walking in 3 or 4 years, at 3 or 4 years, when we are children, we do not know how to even walk, and how to how to um, get rid of the obstacles that are there, and how to take turns, how to move forward, how to move backward. We doesn't even know that. But with some as the time passes on, with some experiences, our brain tries to learn that. How it happens. It happens due to it's based on the previous experiences that we have in our database. So in our database is that it's just like in our mind. In the same way, we are giving data to the machine learning model, and the machine learning or deep learning model takes the data, analyzes and learns the underlying pattern inside that, and tries to perform on the model and gives some answers. So we may not expect that all the answers will be 100% accurate, but yeah, we can expect that the answers are up to certain accuracy. And the next thing is that we as humans can take the raw data and we can read it, but machines cannot do it. So first step is like data pre-processing. You need to follow some pre-processing techniques. Some pre-processing techniques also include one-hot encoding or label encoding or clearing of data, filtering of data, making all into the same units, and many more. But this is a tedious task, and you need to label some data. If it is a supervisor data, you need to label that, and many more things. But the thing is that in the Azure services, in the Azure Cognitive Services, you doesn't need to do all those things explicitly, like going and using a one-hot encoder or label encoder, and you don't need to pre-process, undergo all to some hectic pre-processing techniques. So you can directly upload the images. The deep learning model inside the uh, Azure Cognitive. The deep learning model inside the Azure Custom Vision automatically detects the best algorithm, whether to use the ResNet or Inception or Ensemble, or it may also even go through the transfer learning, where the output of the one neural network is given as the input of the another neural network. So it does that. It automatically does in such a way that it maximizes the precision, recall, and FN scores. I'll get to you about the what exactly is precision, recall, and FN scores in a moment or so. Before going on to that, we need to know what exactly is machine learning. So for anyone professionals out there, this is even targeted for the basics, and does explain only up to a basic level, with taking some minute analogies. So if you want to explore machine learning and deep learning at your fullest, which here it covers convolutional neural networks. It takes an extra edge traveling over that. So yeah, before jumping on to that, let me just quickly wrap up the machine learning. So machine learning is a subset of artificial intelligence that allows system to improve, to learn and improve from the data without being explicitly programmed. So as we have previously discussed that without explicitly being programmed, machine learning is a branch of AI that makes the model to learn on its previous data, and to perform on the unseen data and get a result on that. It may be regression, it may be prediction, or it may be classification, or it may also be a clustering. The classical machine learning is divided into two major things. Also, the another one is reinforcement learning, but we are not interested in that. The two main things are supervised learning and unsupervised learning. So supervised learning is a task-driven approach, and so unsupervised learning is a data-driven approach. So the supervising learning includes classification, regression, whereas the unsupervised learning includes clustering, association, dimensionality reduction. So what exactly is classification? What exactly is regression? This is so classification and regression. regression are just predicting over some continuous data points. We want to predict whether today is going to rain or not, or something like that. Any common predictions that goes all around the regression. And the classification is like, if you have some label data, and you want to classify them among different labels. So classification helps in that. You're just placing a group of data points under one label and separate it or classify it in a separate group. That exactly means that classification is. And clustering, on the other hand, unsupervised learning is an unlabeled data. You does not give any explicit label to the data, whereas all the data points are automatically clustered based on their distance or based on the algorithm that you use specifically. If you go for k-means, it just uses the distances, and distances are also of different types. You can go with the Manhattan distance or Euclidean distance or any other type of the distances. And data points are clustered based on the distance or based on some different hyperparameters that depends on the data what you choose, and that depends on what algorithm exactly what you choose. So the objective of the supervised learning is predictions and the classifications, whereas the unsupervised learning objective is structure or pattern recognition. So there are many models which I'll be coming onto the in a later part of the later part of the slides. So what's the difference between artificial intelligence, machine learning, neural networks, and deep learning? So this is also we have discussed. So today we are using custom vision. So our main motive is that we are basically we are performing some classification algorithms on the data. We are just classifying. Today we are going to take a data set of dogs basically, and we are just performing the classification on that dogs. Where it just recognizes the which breed of dog does it belong to. That is what we are going to do. So it basically broadly comes under the category of a classification. So introducing the custom vision, basically you need to perform this classification via different algorithms like you can go with support vector machines, or the basic of the basic you can go with logistic regression by using the sigmoidal activation function, or sorry, sigmoidal function, not activation function. Activation function comes under the neural networks, where you just apply all the filters across the neural networks, and each neuron in the neural network must be fired via a function which is called as activation function. So yeah, before discussing on all on that, I just wanted to introduce custom vision, because you doesn't need to know all these things in order to use the custom vision, because it's a very lightweight, I would say, service which is provided by the Azure, where you can blindly test train the model and perform validation and testing on the model. And the model is quite intelligent that it doesn't use one single model, but it's quite intelligent that it can adapt to itself based on the parameters, based on the training data, and it tends to give much of the precision and much of the accuracy. You'll get more accuracy and more precision instead of hustling around which algorithm to use and trying out three or four proper algorithms and evaluating the all the accuracy precision. Azure does all that automatically. It doesn't get that much hectic. So your own custom vision model in 3 steps. That's it. Just upload the image, label the image, train the model, evaluate the results. It's that simple. If you go for a normal machine learning classification algorithm, you need to pre-process. Firstly, you need to collect your data set. Obviously, data set is available in Kaggle or any other outsourcing platforms, and you need to pre-process the data. You need to filter all the images with a certain grid, and grid in the sense you need to reallocate the pixels. You need to resize your image and reshape your image as well in order to train that. And you need to perform some pre-processing techniques on your images. And after that, you need to train the model. You need to pick the best algorithm, which you may not know exactly which algorithm performs the best, because it depends on a lot of the parameters and hyperparameters that you plug in. Yeah, you need to try out with some different algorithms, and you need to also adjust all the parameters and the hyper parameters as you go, and you need to adjust the parameters like learning rate, as well as the batch size, number of epochs, how much you need to train it, and for each and every algorithm, you need to compare and evaluate the results and test your model. So custom vision eliminates all the hustle of doing this. Just upload the model, sorry, upload the images, label the images, train the model, evaluate your results. That's it. It's that simple. I'll be showing you how to do that. I'll come back to that while the model is training because you can save some time there. First, head on to your browser and go to the portal.azure.com. While you go this, I'll share you a chat. Sorry, I'll share you a GitHub repo so that you could follow that step by step. I'm posting that in the chat window. So this is the GitHub repo link that I'm providing you. You can just open that and the entire thing is there in the very step-by-step manner. You just clone the repo. I'm expecting that most of the people here know the basics of Python as well as the GitHub, how to use GitHub because it's quite basic. Just clone this repository and I'm just going with the part 0 of that, install and configure tools. So installing the editor VS Code, you can use the basic, the notepad also to do that because it's a quite basic project. And because very minimal upfront investment for this from the client side is required because everything processing all done with the is done in the cloud Azure itself. Just if you want to integrate in the any of the projects as by performing an API call, you can do that. So you can head on and install the VS Code. It's quite easy. Just type VS Code download or VS Code install and go to the yeah, it's free. You can download that from your Windows, a Windows store, or you can also download from the this code.visualstudio.com. You can also download from that. I'm not just going into that and all because it's quite basic. And also download Python. You can also download Python. You can integrate this in any of your languages, not only Python, but I am choosing Python because it is of machine learning, and most of the machine learning and deep learning projects are written in the Python. So I'm preferring that language. If you have any existing language, or if your project is in any other language like Java or JavaScript, you're good to go. You can perform just an API call using an Ajax, or you can also go for async await promises, or Axios is the best framework that you can perform in API call. So you can download the Python over here. And yeah. Hello. Yeah. Uday Reddy. Do you have any doubt regarding this? I cannot hear you actually. Do you have any doubt regarding what we have discussed until now? Or yeah, depending on on our pathway. After we start the project, so now that this, I've sent this link to the in the chat itself. You can directly go with the link and just clone the repository. I am hoping that how to how to clone a GitHub repository, and go to the navigate to the portal.azure.com where I've went to that, and click on this plus icon, or create a resource and search for the custom vision. So this one, the custom vision, I'm highlighting with my cursor, custom vision. Go to this, click on that, and click on create. Yeah. And inside the create options, click on both as you are performing both the training and prediction. So if you are using any template models, then you can directly go for the prediction itself. But yeah, here we are also training the model also. So directly go for the training, both training and prediction. Uh, Here my subscription is Visual Studio Enterprise subscription. If you have any different subscription, you can also opt for that. And the resource group which it belongs to is, if you have any resource group existing, you can integrate with that. Right now, for instance, I'm creating a new resource group. So my resource group name is dog classification, dog class. Okay, I'll perform like dog class. Mhm. Excuse me. Yeah, and region, try to pick the region where your project, your custom vision is available. Mostly in all the regions it is available, as well as pick to the region where your users are residing close to you or close to your service. So I'm residing in India, so I'll go with the India. My instance name, so it's US custom viz run row Vishnu. You can give your any name, but make sure that it is a unique name. It's a unique name. And the pricing tier. Actually, you can also go for, if you have any free tier, you can also go for the free tier subscription. But here I'm going for the standard tier subscription. And yeah, the pricing tier here also I'm selecting standard tier subscription. Review plus create. Yeah, just look up, review all your template parameters and click on the create. So deployment in progress. Let's wait for a minute or so because our service is getting deployed. Let's see the thing. Whatever I've discussed, that is mentioned in this GitHub repository. I've shared you with the link also of this repository. So you can also follow that step by step when I'm going. The deployment still is, yeah, the deployment is completed. I am clicking just go to resource group. So this is my resource group. Uh,
ఇది మా వాడు
so
అనమాట
yeah.
ఈడు. ఆడు మీటింగ్ పెట్టాడు, ఆడికి సర్టిఫికేట్ కావాలి, ఆడికి సర్టిఫికేట్ వస్తుంది, అందుకని మీటింగ్ పెట్టాడు, ఈవెంట్ చేయాలి. కానీ పాపం.
Mm, the next thing is go to this navigate to the custom vision. You can also type custom vision directly in the Google and just log on with your account where the Azure is present. The account which is associated with your Azure. Just log on with that and click on the new project. Enter project name. So project name, I'll just go with the doc classification. Okay. I'll just go with the doc classification. Project description, I don't want that. Custom vision S0 because that is what my pricing tier it belongs to. And I'm going with the multi-class as I just want to give single tag per image. I don't want to complicate this by using multiple tags per images. So just one tag is enough for that, for the dataset what we are performing right now. One we are going to cross check with this. Enter dog classification for the product name. It's yours. You can enter any of your name. Next to the results, select the key of enter, which will use in the name during the setup. For the project type, select classification. So the classification type, Select multi-class or docs of one breed. Yeah. For domain, select general A2, create select project. I think so. We have followed the same thing. Doc classification is the name. Resource is S0. Yeah. Because that is our pricing tier that we belong to. Classification, yes. Multi-class, general A2. Yes. Create project. Click on the create project. It just takes some time. Just hang on with that. Yeah. So our platform, custom vision platform is ready. Now we are just going to add some images and keep it for training. So you can add your any of your images, but the thing is, I have told you that to clone this GitHub repository, right? So this GitHub repository even contains the testing as well as the training images also. You can use your own images, but here for showing the same things, I am using the images which are provided by the just provided in the GitHub repository. Let's go over here and click on add images. So I have this ML model custom. This is a GitHub repo that I've cloned. Training, go to training images, and I've provided you with some images of some dog breeds. The first one is the American Staffordshire. We have 8 images of that. So click on open. So these are the images. Add a tag because, and this is all under supervised learning. So you need to provide the tags and the labels of the images beforehand, and you such that it would classify based on the tags and the labels itself. So just click on my tags and give a tag name. This is an American dog, right? Uh, let's keep a name same. Let's keep the name same with the breed name that we are going with, the American Staffordshire. I just copy all the 8 images, open, and give a label same. Okay, American Staffordshire Terrier. You can also give it a different name, but I just wanted to keep all the individual label names as the and the group label name as same. So that's why. Click on the upload files. All the files, 8 files will get uploaded. Yeah, done. So these are the dog images of the American Staffordshire breed. Next thing, what I wanted to go is here. Click on add images and Australian Shepherd. I just wanted to select all the Australian Shepherd and Australian. Yeah, I'll just keep Australian. Click on the upload button. Yeah, done. And similarly proceed with all the breeds that we have. Australian is there, next Bugle. And yeah, give a label as Bugle. So you can also see how many images are there and how many classes. I mean, how many labels are there exactly. Bugle, yeah, German pointer. Select this German wirehead pointer and German. Give a tag or label as German. Use something for it to upload. Yeah, done. The same way, add this shore key also. So right now we have I think so around 5 breeds of dog. I think so it's enough. We have a good amount of training data, although it is very less, but yeah, for this demo it's fine. Click on this train button. Go for the quick training. So if you want the highest amounts of precision and accuracy and recall values, you can go with the advanced training. But right now, I'm just going for the quick training because in order to demonstrate. And my probability threshold is about 50%. If you want to tweak your model according to your needs, you can just increase or decrease the probability threshold uh, based on how you get the accuracy, the results. Yeah, it takes some time for training. I think so. It takes around 5 minutes of time for training. Meanwhile, we just come over here and we'll just explore on what exactly is precision, recall, F1 score is about. These are also called that's the evaluation metrics of the model, where every model is evaluated based on these parameters. So precision is nothing but it measures the proposition of true positive predictions among all positive predictions made by the model. It answers basically of all the instance model predicted as positive, how many are actually positive. Hang on a bit. If you still did not get what exactly is precision is, just wait for a minute. I'll be taking one a real life example and explaining you how what exactly is precision and recall is. The formula of the precision is given by true positives divided by true positives plus false positives. If you don't even know what exactly true and false positive also, just wait for a minute. I'll be clearing that also in a moment or so. And what exactly is recall? Recall is also called as sensitivity basically. Recall measures the proposition of true positive predictions among actual positive instances. You know, it answers the question of all the actual positive instances, how many did the model correctly identify? How many the model correctly identifies the of the out of all the actual positive instances. That is what exactly what recall is telling about. The formula of the recall is true positives by true positives plus false negatives. Yeah, I'll let's take one quite simple example in order to understand this. Precision and recall. Let's take one small classification algorithm. Um, let's take it as a support vector machine. Or okay, does not discuss or disclose about the model which we use, but basically assume that you have taken any of the machine learning model for the classification of email. So you have two labels. One is for the first label is spam, the second label is not spam. Make sure that we are going for the classification, not for clustering. So we need to label that email. So leave about how we label that, how a machine learning model is, how an email is labeled. Leave about all these things. Just we are here to learn about the precision and recall in a very bird's eye view. So true positives are the emails which are correctly predicted by the machine learning or the deep learning algorithm as a spam. Are you getting it? So true positives are nothing but it is a spam. Okay, the mail is a spam mail, and the machine learning or deep learning model, I'll just be calling model from now. The model is also predicted it as spam. So it is called as true positive. The false positive is nothing but the email is incorrectly predicted as spam. Actually, the email is not spam. It is false. The false it exactly tells that it is not a spam, but it's a positive. False, but it's a positive. Positive in the sense the model has predicted it as a spam, but it's not actually spam. That is called as false positive. The third one is false negative. It is also in the same way. The email is not, the email which is incorrectly predicted as not spam, but it is actually a spam. The email is a spam email, but it is incorrectly predicted as not a spam email. That is called as false negative. I hope you've understood this. And the precision in spam email is that out of the emails that the model predicted as spam, how many were actually spam? So assume that we have a group of 100 emails which are labeled as spam and not spam. Okay. Assume that inside the bunch with the bunch of the 100 emails, I have 23 emails which are marked or labeled as spam. Okay, which are actually spam, like not labeled, but which are actually spam. I know that out of the 100 emails, the 20 emails are actually spam. But precision tells the thing that the machine learning predicts some 35 emails as spam. So out of the 35 predicted, uh, the machine learning or the deep learning model predicted as 35 emails as spam. So out of these 35 emails, how many are actually spam? 23. We know that it is 23. So the difference, this gives the precision actually. So how many are actually spam out of the predicted spam emails? So if I have actually only 23 spam, but the machine learning the model just predicted as 35 as 35 or 34 as spam. So how many are there in this 35 which are actually spam? That is determined by a metric called precision and recall. So what exactly is recall? So out of all the actual spam emails, how many did the model catch? I have 23 as actual spam emails. So how many emails did the model caught as it is spam? That is exactly given by the metric recall. And you also need to maintain a good balance between a right choice or right balance between a precision and recall. So if you don't know what exactly you need to go with, you can go with an F1 score, which does make a quite good balance between the precision and recall. So you can tweak around the F1 score and make it balanced. So before going to all these machine learning models that I have mentioned, let's see whether our model got trained or not. Yeah, our model got trained, and we have got 100% precision recall and AP average precision. Yeah, we have got a great precision actually. Uh, yeah, it's a great thing because I have told you already that this Azure Custom Vision takes the best possible algorithm based the best possible parameters and best possible metrics. Not best possible metrics, yeah, best possible parameters as well as the best possible hyper parameters in order to train that model and best possible algorithms that are available to which suits that exactly data set what you have provided. Okay. So after getting this, our model got successfully trained. So right now we need to use this model, right? So just click on this quick test. Okay. Click on this quick test, and you can just go and browse some local files. So I have downloaded an image of a dog actually. I'll first show you the image of the dog so that you could get an idea. Uh, okay, let's see. Let's go to desktop. I'm locating my file where I have downloaded an image. So this is an image of the dog, Sharky. I've taken this Sharky dog image from the internet. You can also download an image from the internet. That's not a problem. I'll do that. Yeah, we'll take this any one random image. Yeah, take this image, save image as download one. We don't even give a proper name for that. Go to this, click on browse local files. I just want to go with this download one and upload this image. Right now I'm testing this image. Yeah, this perfectly identifies it as Sharky dog as a 95% probability and Buggle with 1.8 and others with the rest of the probabilities. So the highest probability is 95, which is very great in determining. So the Shorky is the dog that we have uploaded. We also know that it's Shorky dog. And so yeah, our model is working very fine. You can go and get a quick test of your model and you can perform the same thing with even with the batch uploads. But if you want to integrate with your SDK, let's click on this publish. Take a model name, give a model name. I'll give dog model one. Okay, dog model. Let it be dog model. Resource, I'm just going with the custom vision Vishnu, where we have created that in the Azure portal. Click on publish. It just takes a minute or so for publishing. Yeah, after publishing, you can see that there is a prediction URL tab. Open your notepad. Open your notepad and copy this link. As well as copy this prediction key. Copy the prediction key also. So I've done that and click on the got it. Head on to the settings tab. Okay, settings tab. And here also copy the project ID. Project ID. Okay. Yeah. Right now we are good to go. In this link, what we have copied. Let's go there. Let's go there. So we have copied all these things. Go to the predictions tab. Yeah. Go to the performance tab. Right now, we can see that our patient recall and API is there. Right now, we are going to take this model and perform and get. We have also got an API for that. We are including in our SDK directly. Head on to your VS Code, which you have downloaded first. I'll just go with a new file. I'll take a new file. Uh, let's go over here and create a new folder. I'll name it as live demo. I'll open VS Code via this. Open with code. Okay, I'll just open with this. Here, create a virtual environment. Open your terminal. Right now I'm using PowerShell. If you can also go with the Windows subsystem for Linux, or you can also pick any of the bash environments if you are using the Mac or Linux distributions. I just wanted to create the virtual environment. Python VENV. The virtual environment name is VENV. I just created a virtual environment. Just give some time in order to create all the dependencies. Yeah, virtual environment has been created. Now I am activating the virtual environment. Right now I'm using PowerShell. So this command is for PowerShell. So the command is virtual environment name, which is .env in my case. Scripts activate .PowerShell1 PS1. Click on that. You can see that my virtual environment got activated. If you're working with the bash environment, so the command is different. It is of something like source, your virtual environment name, and bin activate. I feel like you can just browse that and get it how to activate a virtual environment in your bash environment. But for the partial is VNV scripts activate dot ps1. In this, I just wanted to s- go and grab my requirements.txt file. You know, uh, let's go on for this. Okay. Uh, Go and grab this. Store the necessary credentials. And this one, go and grab this. Before this, yes, yeah. Inside requirements.txt, add the following. Just copy this in the install packages section. Just copy this. Okay, and go and create a text file, in the environment, not in the .venv file, in the environment. Type it as requirements requi it's requirements.txt. Make a txt file. The name is here, which you can also give your any of your name. Just copy these requirements.env and Azure Cognitive Services Vision Custom Vision. I'll explain what exactly both are this. You know that Azure Cognitive Services is a platform, is a requirement which tries to make you the working of the API or the link what we provide. It just fetches the data from that. It posts the data in a JSON payload to that to our existing model where we have trained that, and it also fetches the results from that. So for all these things, in order to get smoothly processed, we use Azure Cognitive Services Vision Custom Vision module. And .env module is used for right now we are all keeping these credentials inside our project, right? these credentials, the custom vision prediction, as well as the our key, as well as our project ID. These are quite confidential. You should not share it directly. Right now I'll be deleting after this, but yeah, you should not share it directly because any person can use your services and it is paid, right? It's pay and it is pay as you go. So you need to be very much careful in this. You should not directly embed that into your project. Rather than that, create a .env file and place all your credentials in the .env file and plug in those env file that env credentials into your project file. Okay, and make sure that while pushing to any of your GitHub repository, try to ignore that. Must make sure that you definitely ignore that. That .env file. You need to place that .env file into .git ignore. Okay, then only your file get ignored. The .env file doesn't directly get ignored. If you even if you commit it under the .env file, it is committed and it is publicly available in the repository. You need to make sure that you should place that into the .git ignore file such that it doesn't gets committed. Okay. Right now, before we telling all this, just save, go ahead and save this. I just wanted to download all these things. So pip install, you can also download it manually by directly typing it, but I just don't want to do that 2 times. So pip install r requirements.txt. So this is the command which is used to download all the requirements. I just placed all the requirements and that's the command which is used. Let's wait for a while such that, yeah, both the requirements got installed. Okay. And go ahead and grab this env file, copy this env contents of the env file and create a .env file, .env, place all these things, endpoint. So go to your copied notepad and copy this up to only here, not the entire link. You just need the endpoint of that. So HTTPS custom vision prediction cognitive services azure.com with the /. Copy only up to that. Okay, be careful that copy only up to here. HTTPS custom vision prediction.cognitiveservices.azure.com. Don't copy all these things. Custom vision prediction, that is not required. Only azure.com. Up to there it is required. Be careful. Make sure that you copy only up to azure.com. And the key prediction key. So what is your prediction key? We have also copied that key over here. Copy and paste this key over here. Project ID. You have also copied the project ID from the settings or gear icon. So paste this project ID also. Make sure that it does not include any extra spaces because it won't be worthful. And published iteration name is not dogs by default, but I think so. We have published that as dog model. If you are skeptical about which iteration name we have used, you can also see that in this link. Dog model is our iteration name. Just copy that and paste over here. I think so. The REN file got ready. And the next thing is uh, inside that. Yeah. So copy this. Go ahead and copy this. And load all the env files. We have created that env file. In this, from this code, we are loading all the env file, the variables of the env file from there to our project. And perform this prediction. So yeah, right now we are done with this, done with the code. This is a small piece of code which is available in the GitHub repository. You can directly copy paste that code. Because all the variables are placed in the env file. No need to tweak around all the things, even the variable names, all our variable names. Just one thing is required that you need to give your image. This is with open read buffer. Okay, we need to give a image for this. So for that one, I'll just place an image over here in this live demo folder. This dog show is there, right? Or download. I'm gonna just copy both the images and I'll be placing in this live demo where we have downloaded from the internet. I'll just use the name of this dog underscore sho dot jpeg dot jpg pog underscore sh. Make sure that the file name matches with the photo image name dog sho dot jpeg. Yeah. After that, just go ahead and run this Python file. Click on Python, type on Python, predict.py, right? Yeah, as you can see that the dog is of Shorkey of 75%, Bugle of 20%, and Australian of 2.36%. Yeah, basically we know this is Shorkey. I can open the image and show you the, yeah, this is another image. This is a Shorkey image. Sorry, this is a Shorkey image, and we also have a download of that download image also. Both are same, basically. So it performs as Shorkey as 75%, which is obviously true. So yeah, this is where we have built trained a model under an hour or so. This under an hour, that's it. And it took me a lot of time to explain you even. You can even perform the prediction within 5 minutes. So leveraging the power of this custom vision is quite great actually. You can just make the machine learning models and use it on the fly, on the go, without any, without any mathematical, scientific, statistical knowledge. Just place your images, train the images, as well as label your images, label the images, train your images, predict the images what you want directly from your SDK. From your project, wherever you require, just include this and you can straight away leverage the power of custom vision. With that said, our event most probably comes to an end. Let's see this GitHub repository. Yeah, we should see the output. Yeah, we have seen this output. This output may vary because the images what we have done is from internet, right? So yeah, yes, that's it. That's it, guys. We have completed. We have done of this making the model, training the model on the fly, on the go, within an hour or so. I've also attached you all these things, the different types of machine learning models, just for your reference, which is not all required. Which is not all required whenever you're using, the custom vision, because it handles all the things on itself, whether it is machine learning, whether it is deep learning, whether it is just prediction, just a linear prediction. It just sees on itself. But I just wanted to highlight you what are the different types of algorithms that we have. First one is regression, basically. Most of you, I hope so, most of you know that the regression is the basic form of the machine learning model. Just prediction of the continuous form of data. If you just want to predict, right now, if you take a simple linear regression where there is one dependent variable and one independent variable, we just form an equation or make an equation which shows a linear dependence between those two variables. That is, for the first one is the independent variable, and second one is the dependent variable. Yes, we are trying to form a equation. We are trying to fit the data into one equation, and we are plugging in the values of that x values, and we are getting the y values at the output. So we have just made a small, a basic linear regression model, which does find the relationship between the predictor variables and the output variables. So there exists another form of regression also, that is multiple linear regression, where there are like large number of above two, I would say, large number of independent variables and basically one dependent variable. You can also go with the multivariate regression, which is of one dependent variable and multiple dependent variables and one independent variable. So there exist lots of regression models actually over there: multiple regression, multivariate regression, simple regression, and many more. But these are used for regression or prediction task. And the second one is, you can see over this an image. This is of logistic regression. So logistic regression is of a very basic regression model where it is used for majorly classification task. we use a sigmoidal function in order to classify the data points, and it only does of the binary classification itself. The third one is of KNN. KNN stands for K nearest neighbors. This is a non-parametric supervised machine learning algorithm where no parameters are mostly considered. Just gives a new data point is given, and from that new data point, all the distances from that new data point to all the data points are calculated. Basically, the distance you can take it as a Euclidean distance or a Manhattan distance or Minkowski distance. You can take any of the distance that you need, depending on the problem what we have. It just calculates all the distance with all the data points, and it just goes on with a rank, giving a rank to each and every distance that we have calculated from the ascending order, like lowest to highest. And depending on the what value of k that you choose, which is very important, the point is assigned to a category A or category B, or depending on how many categories there are. I hope you've understood what exactly is KNN. And this is the thing where I just wanted to show you the underfitting, appropriate fitting, and overfitting. So machine learning model, I hope so you're very familiar with the bias and variance of that machine learning model. So bias is a bias I could explain in such a way that it's an error in a machine learning model where the machine learning model tries to learn is too simplistic that it doesn't try to learn a lot of underlying patterns in the data. Whereas if you go for the variance, it is also a type of error where it tries to learn a lot of the underlying patterns along with some noises. Each and every data set contains some noise. But this variance is an error where machine learning tries to be so precise that it even learns the noise with the underlying patterns also. So with the variance, it just performs very, very good on the training data set. But if you just go with the testing or validation data set, it fails in the testing or validation data set. Whereas the bias doesn't even perform well on either the training data as well as the testing data. Right now, I have explained you the bias and variance also. So you need to find a right fit between the bias and the variance. And bias is also an inversely proportional to variance. So you need to find a good fit where you need to balance both the bias and variance. And you need to go for an appropriate fitting model. You should not underfit the model, making it too simplistic. You should not overfit the model, making it too complex for the smallest possible data that you give. So you need to find a right balance between that, and you need to appropriately fit that. The next one is of support vector machines. This is an extraordinary algorithm that we have in the machine learning. Support vector machines, it just finds two support vectors, which are the two closest data points that are available in the each class of the data set. And it tries to find one line which is called as hyperplane. It tries to find one hyperplane which is quite optimal. So how to determine a line which is optimal? That is depending on the margin length. It is also called as maximum margin. It is the algorithm tries to find an hyperplane which is which has the quite maximum margin. So margin is nothing but the distance between the two support. Assume that here is a support vector with one class of dataset. Here is a support vector with another class of dataset. As you can see over here, it tries to find a plane which has a maximum of the margin. Okay, so this is a linear. This is linearly separable dataset. Okay, here you can see that the blue diamonds and yellow circles where you can find an optimal hyperplane between this point as well as this point. You can find an optimal hyperplane. But what if all the data in the universe doesn't be linearly separable, right? There are some non-linear data sets, something like this, where the red squares and the circles are dots, blue dots. You cannot draw a straight line separating both the things. So here comes the thing called the kernel trick. So kernel trick is an intelligent way of separating making the non-linear data also into linearly separable data. Just uh, raises the data points, decision surface. It just raises one or the cancer or the normal data set, normal gene data set, either of the data set. It just raises to one dimensionality. It just increases or decreases the dimensionality of that, such that it gets separated. You can see that in the 3D mapping. You can clearly see that these cancer cells which are red cannot be separated over here. But if the plane is raised, if you take it from a different plane, if you transfer the plane, transformation of planes happens over here, then you can separate it. Here the decision, it can be linearly separable. So it is called a kernel trick. And this is a decision tree. So decision tree is also it's a straightforward approach basically, I would say. Decision tree is the very most intuitive approach for the humans also to understand. So here we have used ID3 algorithm, which is transfer iterative dichotomizer algorithm. So basically, it does by leveraging the facts of information gain, entropy, and by using Gini index as the parameters to decide the each and every node of the decision tree. And also there are some ensemble methods which are called like bagging, boosting, and stacking over that. So bagging is nothing but bagging just stands for the bootstrap aggregation. It just is nothing but just take one data set and bootstrap all the data set into different each subsets, and just apply an each different classifier on that, such that it classifies and gives one output. After getting all the outputs, go with the majority voting or majority polling. There are still even different polling techniques which are used at different particular points in your according to your data set. But taking it as the generalized thing, we are just going to the maximum voting technique, where all the decisions are voted on their maximum times which it occurs, and the maximum number of time which the data set occurs, it is taken as that classifier. That classification is taken basically. That is called as bagging. And boosting is nothing but and bagging is a parallel process, whereas boosting is a sequential process. In boosting, the data set is first passed through a classifier. So that classifier identifies something as correctly, and something says wrongly as predicted. So the wrong things, the wrong entities of that classifier are increased. The weights of the wrong classifier are increased and passed to the next classifier, such that they are given more importance and they are given more training. I hope so you all know what exactly are weights and biases. Weights are nothing but those are the entities which establish the importance of that particular neuron or of that particular feature in the data set. That this shows the importance. So it increases the weights of the wrongly detected data sets and subdatas, and it passes to the next classifier, so that the next classifier also classifies that, and it all takes place until up to a certain level. And you can also emphasize many stopping techniques for the boosting also. So yeah, boosting is a sequential process as well as bagging is a parallel process, and that is all about. There are still a lot of machine learning models, but you doesn't need all those things in order to use custom vision. This you see, you are eliminating all that hectic things and just uploading your images, labeling images, and you'll just get the output. That's it. It makes the workflow so easy. Probability and AI, yeah, no model is perfect. The probability indicates how correct the model believes in the answers. Yeah, you all know that. So with that said, we have came to an end. And what's next? If you are curious about what exactly is all this machine learning and deep learning, you can go with the object detection. The best algorithm that you can explore for the object detection is YOLO, which stands for UND Lopens. It's a deep learning neural network algorithm. And you can also create custom models using TensorFlow or PyTorch, which is a framework for the neural networks. With that said, I just want to end this session. If you have any doubts, feel free to ask that. Okay, since there are no doubts, you can you're free to reach out to me on LinkedIn as well as in the chat. You can also chat with me over here. Yeah. On that note, with that said, thank you for attending this meet, and I hope so you have gained some insights on what exactly is custom vision, and how can you train the model and deploy that, and call via an API. and include it in your project. I hope so you're all clear with that. And yeah, thank you a lot for joining this meet actually. Yeah, with that said, I'm Rohit Vishnu signing off.